I'll do it soon. I'll do it soon, baby love. Alrighty, guys, welcome back. Lately, we have been talking about integration techniques, specifically partial fraction decomposition. And last time I showed you kind of the basics of partial fractions. We worked a few problems in that nicest of all possible cases. Today, I'm going to show you those less nice cases. And we will work as many problems of that sort as we can. Also of import is exam 1, which is certainly drawing near. So I would like for us to establish the date for exam 1. I don't believe we've done that yet, and I want to make sure everybody has enough time to prepare, get their shit in order. So let's do all of that today. Let's see if I can find the PFD Bible. Back to that. Oh, did I not save that? Okay, that's okay. Okay, wait, maybe. Yeah, there it is. Okay, good. All right, let's do the thing. So at the top here, you've got your partial fraction setup Bible. We're going to refer back to this a few times today. But before we do any of that, we got another thing. So this is MAC2312, section number 004. That is a Calc 2 class. And today is the 20th of September, 2020. I want to talk about exam 1. And then we're going to finish section 7.4 on partial fractions. And that will be the last bit of new material on your test. So if you look at your syllabus, you will see that after section 7.4, there is just one section that is on exam 1. That section 7.5 is a summary of the previous things in chapter 7. So this section, which we will cover on Wednesday, is going to be very simple in the sense that you don't have to necessarily learn any new techniques. It is still very valuable because it's going to kind of help you decide which technique to apply to what integral. So we will spend a day on this section, and that will serve as our review for the test, basically. Now, I don't believe I've published a study guide for you. Let me take a quick look here because I've just got too much to keep it in my head. Yeah, you do not yet have your exam 1 study guide. So I will publish that today. And that means that the soonest I would like to have the test is the 27th, next Monday, because that way you have a whole week to work the study guide. So let's talk about the test in a little more detail. So exam 1. We'll cover sections 5.5 through 7.5. And oftentimes I'll let you guys vote on the day, but I think because we're a little bit behind schedule and I really don't want to lose time and there is no sooner date I would be comfortable having the exam on the 27th, we could do it this Friday, say we're going to cover 7.5 on Wednesday, and then have the test on Friday. But I want you guys to have that weekend to study. I want to make sure that you have enough time to work the study guide problems and get feedback on them. So it will cover these sections and take place on 9/27, which is next Monday. So we'll go ahead and set that date in Canvas. I don't think we have that set yet, right? 24th. Yeah, that was the original plan, right? Should have been this Friday, but we're going to push it past the weekend to make sure you have time. Change that. This to there. So the test isn't written yet. There isn't anything in there yet for you, but it will be on the 27th, next Monday. I want to talk a little bit about the procedures around exam one, ways you can study, things you can do to help increase your probability of success on exam one. And that's it. Yeah. Okay. So you can take the test online or at the testing center. Either way, it has to be during class time. Right. So this is a hybrid class, which is called a synchronous class rather than an asynchronous online class. The synchronous part of the hybrid classes means we do things at a set time. We do them at the same time, all together. So whether you're taking it online here with me or at the testing center on the Northwest campus, you're going to do it on the 27th, 1 week from today, during class, right? During class time. If you are going to take it online with me, I have some rather strict proctoring guidelines. You'll be using HonorLock, which will record your screen, your webcam, your web traffic, inbound and outbound. You will also be required to sign into Zoom on your phone. And you're going to have to set your phone up somewhere off to the side, behind you or above you, I don't give a shit, somewhere I can see your desk, your hands, your lap, and the paper on which you are writing. All the things that a professor would want to see. The reason for that, I hope, is clear. We want to preserve the value of your credential. If you get a Calc 2A from a place that is known to have lots of cheating, then nobody's going to give a fuck, right? Including the universities you're hoping to transfer to. If you get an A in Calc 2 from a place where there is known to not be a lot of cheating, then that will mean something, and places and people will consider that credential valid and meaningful. We want you to be in the latter camp, not the former camp. So I'm fighting very hard to minimize cheating here. It's up to you. If you don't want to deal with my online proctoring stuff, which I totally understand, you're more than welcome to take it at the testing center. If you're going to do this, you need to make a reservation. And to do that, you should contact me. A Canvas message would be the best way, because that automatically puts in the subject line your name, the section number, class, and all that good shit. So if you want to take the test at the testing center, rather than dealing with my Zoom on the phone and HonorLock on the computer, online proctoring mechanisms, that's fine. Send me a Canvas message saying, I want to take exam one at the testing center. I will set up a reservation for you for the 27th, and you show up there at class time. So you need to make sure you arrive a little bit early, get in there, get checked in, get ready to sit down. There will be a small window around class time, plus minus 15, 30 minutes, something like that, to accommodate people who have technology problems and things of that nature. But because this is a synchronous hybrid class, we all take the test at the same time. Any questions about where you can take the test or the physical mechanics of how you're going to take the test? I can show you what the test will look like. Obviously, again, differential equations tests is not going to be the same content-wise, but structure-wise, your test will look the same as this one. There will be some true-false questions, 4 of them, worth 4 points each. There will be some multiple choice questions, 4 of them, worth 6 points each. And then there will be 6 free response questions, worth 10 points each. So there are a total of 14 questions on the test. The test is worth 100 points. The free response are worth 10, the multiple choice are worth 6, and the true false are worth 4. My true false tend to be a little tricky, so you might want to look at some of the true false problems in the book, which are similarly tricky and very similar in style. The multiple choice are standard multiple choice shit. The free response questions work as follows. Obviously, read the question. You're going to have paper and pencil. On your scratch paper, you will write out your solution. You're going to solve it just like you would solve any other problem on your paper. Make sure you write neatly enough so that I can read it. And then once you find your answer, you will type just that answer, only your final answer into the box. And you don't need to worry about typesetting the mathematics. Like if you want to type x cubed over 7, you can do this. If you want to type minus e to the x, you can do this. If you want to type plus the natural log of x minus 3 or x minus 2, you can do this, right? So don't sweat the typesetting here, but you do need to type your final answer in the box. If you do not type the final answer in the box, I give you no points. And I don't like doing that, even if you have free response. Even if you have the work on the page, I can't give you credit unless you remember to type your final answer. So please type your final answer in the box. Don't waste time trying to insert math and make it look pretty and stuff. Like, don't bother with that. Just type it as I demonstrated there. It's very important that the answer you type in this box matches the answer on your free response work, right? Matches the answer you would get from the work on your scratch paper. That is, of course, critical. And the breakdown for the points, right? Each one of these being worth 10 points, I feel you should know. Having the correct answer typed in this box is worth 2 points. The rest of the credit for each of the free response problems comes from your written work. And there will be lots of partial credit. You'll be happy to hear, right? Lots and lots of partial credit. That is the bulk of the grading when it comes to what I need to do after you've taken the test. I have to grade your written work. So 2 points for the answer typed in the box, 8 points for the written work. So you want to make sure your written work is clear, legible, and I can tell which bit of work goes with which problem. The usual advice I give for that, just do 1 problem per side of the page. Right? There's 6 free response problems. You'll need 3 pages minimum. It's not that much of a hassle. It's not that much paper. If you insist on packing more problems onto the page, make clear delineations, number the problems, write the problem before you write out the solution. Please make sure I can tell which work goes with which problem and that I can read the work. Once you finish the test in Canvas, you will have to scan your written work. So you finished, you've typed in all of your answers, you selected the answer you want to use for each true, false, or multiple choice. You'll come down and hit submit. On-or-lock will close. You'll still be on Zoom on your phone. Before you exit Zoom, you will use a scanning app, something like Cam Scanner or Adobe Scan, or iPhone users can use the Notes app to scan your written work. You need to look at those scans and make sure they are legible. Then you will submit those scans here to exam 1 written work. I will be looking at these while I grade your test. Right? I will go through your written work. I will mark it up using an iPad stylus. I will mark up your written work the same way I would mark an actual paper test in an in-person class. And based on that written work, I will assign 0 through 10 points for each free response problem. That is how the test is going to work. After you have submitted your scans, then and only then can you sign out of Zoom. Any questions on the mechanics of taking the test? Everybody good? Oh, I see there's something in chat. Yeah, okay, good question. Yes. If you take the test at the testing center, you still need to get me your written work. They have scanners and printers and stuff there. You can ask them to scan it and send it to you. Or you can, let's see, actually, I haven't thought too much about this. So you could still scan with your phone, right? You need to get permission from the proctors there. You don't just whip out your phone in the middle of the testing center, but tell them your professor needs scans of the written work. They may be willing to scan it and submit it for you, or they may tell you to scan it and submit it. Either way, it needs to go to this Canvas assignment. Don't just email it to me or have it emailed to me. It needs to be submitted to this Canvas assignment because the software I use to grade needs to be able to grab in here. So whether you take the test at the testing center or take the test with me online, the written work must be scanned and submitted to the appropriate assignment within Canvas. Coburness, what about the true, false, and multiple choice? Should we submit work for those? As a rule, I do not do partial credit for true, false, or multiple choice questions. If they're right, they're right. If they're wrong, and that's pretty much it. Now, on occasion, very, very rarely, I have given partial credit for one of those questions. For example, if you believe there is a typo on the problem and you don't see the correct answer as one of the options, or if you believe a true false question could go either way, right? Like it's not a clear true false statement. Basically, if you disagree with the question, then sure, give me your work. And if you've got a valid argument there, then I can assign some partial credit. But I'll tell you in general, that really just doesn't happen. I check the test quite carefully. Typos have happened, but they are rare. But only in those sort of instances do I give partial credit for the true, false, or multiple choice. So yeah, as a general rule, only the free response have partial credit. Julian asks, so you notice that this requires you to submit a PDF. Cam Scanner, Adobe Scan, and Notes all will produce a PDF for you. I don't know if Cam Scan, so the specific question mentions an app called Cam Scan. I don't know if that's different from Cam Scanner. The app that I've used, Cam Scanner, outputs PDFs, as do all the other scan apps that I've played with on my phone. I do want it as a PDF. Again, I use a piece of software on the iPad to mark these up. So the document format is kind of important, and the legibility and clarity is important. PDFs are just by far the best way to pass around written documents. So yes, I do want it as a PDF. Please no HIC files, no JPEGs, no bitmaps. If you haven't played with any scanning apps, Google, right? Last time I did this, which was a while ago, Cam Scanner was at the top. And that's the one I have on my phone that I use when I need to do this stuff. It happens. But I was recently told about Adobe Scan. I haven't played with this yet, but I've been told that it is good. It is free. It outputs PDFs that are of high quality, and it's available for both Android and iOS. Office Lens, I haven't fucked with. Swift Scan, I don't know. But yeah, play with some, pick one. And yes, it does have to be a PDF. Okay, I think that's all the questions from the chat. Are there any other questions about the mechanics of the test? Will the multiple choice be easier than the free response? Well, that's a matter of taste. You all have taken pre-calculus. Let me show you one of my old pre-calc tests. Diffie probably doesn't help you with that, but here's Summer B pre-calc. So you can decide whether you think these are harder or easier. I'll tell you that my true false have a bit of a reputation on campus for being difficult. It's not that they're going to require great lengths of work. What they require is a deep understanding of the concepts. So the way I write these things is such that they're very fast if you know what you're doing, and they're quite hard if you don't. So, you know, this point being on the graph is equivalent to saying f of pi is equal to the square root of 2. This is false, right? Because The y value is f of the x value. The true statement here would be f of the square root of 2 is equal to pi. You need to swap the pi and the root 2. But if you don't know the definition of the graph, or you don't understand what graphs of functions are, this is more or less impossible. You see themes, right? The function f of x is negative rate of change from x equals a to x equals b means that this function is decreasing. Plausible, right? And many functions it's true, but it's not true in general. It's very easy to come up with a counterexample. So my true false tend to be a little bit tricky, but not time consuming. And that's the vibe. The same will be true for you guys. So if you know your theorems, you know, and these are things you learn through practice, right? Can you split up an integral over multiplication? Right? Is the integral of f times g the integral of f times the integral of g? That's a question that's shown up on this test. Or if f of x is a continuous non-zero function, is the integral of 1 over f of x the natural log of f of x? These are things that you can very quickly come up with examples and counterexamples for if you have practiced. Those last two are questions that have shown up on Calc 2's exam 1 from the test. So yeah, not harder, just more conceptual and less time consuming. That's the way to think of the true, false, and multiple choice. They're concept focused and they're very quick if you know what you're doing. Very little calculation. Any other questions? Study guide going to be up a little later today. I have to teach another class right after this, then office hours after that. So no later than like 5 p.m. today. Study guide will be up. Oh, and that reminds me, thank you. We need to talk a little bit about the study guide. So the study guide for exam 1 will be posted later today. And if you look on your syllabus, you'll see that the study guides are each worth 25 points. The way you get the credit for the study guide, those 25 points, which is significant, that's a quarter of a test. The way you get those points is by submitting your written work for the study guide in Canvas. I don't care about completing the study guide within WebAssign. It will be posted to WebAssign. It will look like a homework and it will count as a homework grade within WebAssign. But the way, we don't have anything in here yet. What is this? Oh, that's an old class. Yeah, so the way you get the credit for the study guide is by taking your written work for the study guide, all of those problems, and submitting it here in Canvas. You will not get the credit for the study guide unless you submit the written work. It's a good opportunity to practice with the scanner that you're going to use on your phone. More importantly, so let's write this down. We'll post it later today on WebAssign. To get credit, you must scan and submit the solutions, the written work.
Will the study guide go under the homework category?
So completion of the study guide assignment in WebAssign counts as a homework grade. The scans that you submit to Canvas count as the 25-point study guide grade. It's its own thing. So if you look in our grade book, there is a category for homework. The study guide being done in WebAssign counts towards this, right? But this totally separate grade over here, study guide 1 out of 25 points, that's coming from your scans, these. Within this little category here, I'm going to say the study guide grade is not about correctness. It's just graded for completion. So if you have an effort, right? If you show me you've tried to solve each of the study guide problems in your written work, then you're going to get 25 out of 25 points. The only way to lose points on the study guide is to skip a problem or two, or to not submit the written work. So as long as you submit the written work for your study guide and you have some effort for each problem, I'm going to give you full credit. It's basically a free 25 points. The purpose of the study guide is for me to look at your work and mark it up like I would mark up a test. So you can see exactly how I grade. You can see exactly what I'm going to take points off for. And I can tell you, oh no, this is a mistake that you've made a few times here. You need to watch out for this on the test. So my advice, please submit the study guide on Canvas by Saturday night or very early Sunday morning. Because Sunday afternoon, I'm going to go into Canvas and I'm going to mark up those study guides. Not every single problem, but for each person, I'll pick 1 or 2 problems to mark up the way I would mark them on a test. And that way I'll be able to get you some feedback on your written work before the exam itself. I don't want you to have any surprises. I don't want you to be like, oh no, I didn't know I was going to take off points for not having a plus C, shit like that, right? I want you to know exactly what to expect from me grading wise on the test. And I want you to know exactly what you're doing right and exactly what you're doing wrong before the test. The study guide is officially due at the start of the test, right? So if you're like, a little bit behind with the study guide, you don't manage to get it done by Saturday or Sunday, and you submit it, right before taking the test, you're still going to get full credit as long as you have an effort there for each problem. But in order to maximize the value of the study guide, you should try to submit it by Saturday. That way I can get in there and mark it up for you, and you can learn something from that marking process. I always get a bunch of emails at the end of the semester saying, I did all the study guides, why don't I have points for them? Please remember, to get the credit, you must submit the written work. If you don't submit the written work, I can't give you any points. You gotta give me the actual work, right? I know anybody can plug a bunch of shit into Symbolab and write, type in the answers to WebAssign. I'm not interested in that. I'm interested in what you do on the paper. So please make sure you actually work those problems independently and don't cheat on them. For fuck's sake, don't use Symbolab or Wolfram or Integral Calculator, or, any of that shit, Mathway on the study guide. Because if you make a mistake, you're not going to lose any points, right? I'm not going to take off points for mistakes on the study guide. I'm just going to mark it and tell you, on a test, this would be a ½ point. On a test, this would be a 3-point error, that sort of thing. You'll get full credit, even if every problem is wrong. Right? So please show me what you know. Show me how you would perform on the test. That way I can give you some useful feedback. You don't need to be afraid of losing points. Just make sure you submit the damn thing. All right, we good? We got any questions about this stuff? Okay. Test is next Monday. Study guide goes up today. Study guide is due at the start of the test, but I strongly recommend you submit the written work in Canvas no later than Saturday night so I can mark it up and give you some information. Yes, Amanda, that's why I was actually a little bit late getting class started today. So I uploaded the last 2 recordings there. They're running in the background right now and the links are already up. They should be working by the end of class. Any questions about the test or the study guide? I see we got one more here. How many problems are on the study guide? I don't know, haven't made it yet. Less than 20, somewhere between 10 and 20 usually. All right, usually what I'll do is I'll take 1 or 2 problems from each section that's on the test. As a general rule, that's what I do. Okay, let's get into the material. Are there any other questions? I want to make sure we're rock solid on this. Any other questions about the test? Going once. Go in twice. All right, so let's do it. So today we're going to finish up partial fractions. We have from last time our PFD setup Bible, right, or whatever you want to call it, the little table that tells us how we are going to set up a given partial fractions problem. We have seen a handful of examples of the first type, right, where the denominator just has nice linear factors, not repeated, right, no higher multiplicity than 1, and no irreducible quadratics, just stuff like this. So today we're going to address these gnarlier cases. Looking at this, I want to begin just with a little example. All right, so let's write the PFD setup for the function f of x equals, let's do 2x minus 1 over about x cubed plus x times x squared minus 1 times x squared plus x. We have some work to do here before we can even begin writing the PFD setup. What should I do with this stuff first? Good, we need to factor. In fact, kind of step 0, the thing we do even before that is we check, is this a proper rational function? Remember from last time, a rational function, ratio of two polynomials, is called proper if the degree of the top is strictly smaller than the degree of the bottom. Now the degree of the top here, this is a linear function. The degree of the bottom here is 3 plus 2 plus 2 is 7. So 1 is indeed smaller than 7. So yeah, it is a proper rational function, no long division called for. Now that we know that, we need to fully factor this denominator. It kind of looks like it's factored, but it ain't. X squared minus 1, that's a difference of squares. X cubed plus x and x squared plus x each have a factor of x that can come out, and maybe they can be factored beyond that. So first, let's factor this. The numerator is still 2x minus 1. The denominator here, x cubed plus x, I factor out an x here, and I get x squared plus 1. X squared minus 1 is a difference of squares. That's x minus 1 times x plus 1. And x squared plus x, if I factor out an x there, I get x times x plus 1. And now what you notice is there are some repeated factors. There's an x here and an x here. Those can be put together. There's an x plus 1 here and an x plus 1 here. Those can be put together. So this is 2x minus 1 divided by x times x is x squared. Let me bring this up. X times x is x squared. Then I've got this x squared plus 1. He does not factor. He is what's called irreducible. Factors over the complex numbers, but not over the real numbers. What else do I have? I have x plus 1 times x plus 1. That is x plus 1 quantity squared. And then I have this lonely x minus 1. So x minus 1 is a simple linear factor. So he's going to contribute one term to the PFD setup. Both x squared and x plus 1 squared are repeated linear factors. Since the multiplicity of each of those guys is 2, they're each going to contribute 2 terms to the setup. And then x squared plus 1 is an irreducible quadratic factor. This is irreducible. And the quick way to check if a quadratic is irreducible is to compute its discriminant. So if you don't know, or you're having a hard time telling, b squared minus 4ac, that piece from the quadratic formula, he can tell you whether or not your quadratic is irreducible, or this is called the discriminant. If the discriminant is less than 0, then your quadratic is irreducible. Here, b is 0, a is 1, c is 1, so b squared minus 4ac is -4, which is indeed less than 0. All right, so the setup is going to be two x minus 1 over x squared times x squared plus 1 times x plus 1 squared times x minus 1 equals. We're gonna need lots of stuff here. I'll just go left to right. So I'll first write the terms that come from the x squared here. That is a repeated linear factor. So he's going to get a over x plus b over x squared. You have to build up to those. I'll remind you here in your PFD setup Bible, right? If you have a factor of x minus c to the m is that multiplicity, you'll have a over x minus c, b over x minus c squared, c over x minus c cubed, all the way up to that guy. So both of these come from this guy. This guy. Next, I have this x squared plus 1. So I would write for him a linear term like cx plus d over x squared plus 1. Irreducible quadratic factors in the denominator contribute linear terms to the PFD setup. Next, I have this x plus 1 quantity squared. So let me continue this down here. The x plus 1 squared is also a repeated linear factor. So I would write for him e over x plus 1 plus f over x plus 1 quantity squared. And if this was an x plus 1 cubed, there would be another term here, g over x plus 1 cubed. But there isn't. So now we move on to this last factor, which is just a simple linear factor, and I write some constant over him. Right. So this in purple down here is your PFD setup for this function. We're not going to find these guys. We just want to write the PFD setup. All right. Finding all of these constants would take the rest of class. It's a big fucking function. But it's very important that you know how to set these up. If you can set up this thing, you can set up anything. Hypothetically, if this bottom had all been multiplied out, if I didn't give it to you in this like slightly prefactored form, factoring that would be hard. And sometimes you'll need the rational roots theorem, all the factoring tricks you learned in pre-calculus to get that done. Questions on this? Okay. Let me show you an actual problem where we're going to employ some of this stuff. All right, so for our next example, let's evaluate the indefinite integral of 1 over x cubed plus x. Yes. I'll just take that one term from the last guy. We recognize that this is a rational function. It is a proper rational function. The degree of the bottom is 3, the degree of the top is 0. So I'm going to run some partial fractions on this thing, right? There is no obvious substitution. It doesn't look like an arctan or anything we can crank out right away. So the only way to proceed here is going to be to run some partial fractions. It is always nice to tell your reader what you're doing. So I just say PFD, I'm going to do some partial fraction decomposition. This function, 1 over x cubed plus x, is the same as 1 over x times x squared plus 1. So I write 1 over x times x squared plus 1 is equal to a over x from the x factor there, and then a linear term, bx plus c over x squared plus 1, because I know x squared plus 1 is an irreducible quadratic. Then, just like we were talking about last week, we're going to clear out those denominators. I'm going to multiply both sides by x. That will cancel this x and give a factor of x here. Then I'll multiply both sides by x squared plus 1. The result is 1 on the left-hand side. Generally, over here, you get whatever your numerator was. A over x, the x's will cancel, so I'll get a times x squared plus 1. And then from this term, the x squared plus 1 will cancel, so I'll get parentheses bx plus c times x. At this stage, we can use the Heaviside trick, the Heaviside cover-up method. We discussed that last time. If you need a refresher on the Heaviside method, just check out this paper, right? MIT has published a really cute little PDF explaining what the cover-up method is and how it works. It's the shit we did last time, right? At the very end of class on Friday, I gave you a shortcut for finding some of those factors, or finding some of those constants. In particular, as x goes to 0 here, I know this whole term will disappear, right? Because he has a factor of x in him. And that will allow me to recover a. As x goes to 0, this becomes one equals a times 0 plus 1, 0 squared plus 1 if you like, plus b times 0 plus c all times 0. This is the same as saying 1 equals a, right? 0 plus 1 is 1. So we get a out for free. I still need to find b and c. And the bad news is that that Heaviside cover-up method, he won't work for these guys. And if we had repeated factors like this, he won't work for those either. He'll give you one of them, but not the other. So we've gotten everything we can with the Heaviside method. So now we need to resort to the original technique of equating coefficients and setting up the linear system. So what do? We come back here, we plug in any of the constants that we've found. So I get 1 equals a times x squared plus 1 is just x squared plus 1 plus bx plus c times x. I'll go ahead and distribute that. That's bx squared plus cx. And this is the same as, we need to collect like terms on the right-hand side. So I have here 1 equals x squared plus bx squared is 1 plus b times x squared. Linear terms, I just have plus cx. And then constant terms, I just have the 1 plus 1. And the trick is to interpret this left-hand side as 0x squared plus 0x plus 1. And then we set the coefficients of x squared equal to each other. So we learn that 1 plus b has to be equal to 0. 1 plus b is the coefficient of x squared here. 0 is the coefficient of x squared here. We also learned that C has to be equal to 0. And it's trivial, but we learned that 1 is equal to 1. This is what we get by equating coefficients. Which is the main tool that we use, right? The Heaviside method works great sometimes, but it'll not get you everything all the time. So this is the main mechanism that we use. Thankfully, this linear system is incredibly sparse. C equals 0, you get it right away. And this first guy implies that B is -1. Sometimes the systems will be easy to solve like this. Sometimes they'll take a little bit more work, like in our first example last time. Doing the Heaviside trick first makes this easier because, this would say A plus B equals 0 otherwise. The coefficient of X would be maybe a little bit more complicated. Just by having found as many things with the cover-up method as you can, you save yourself time at this stage. So I know A is 1. I know B is -1, and I know C is 0. So what I've learned is that 1 over x times x squared plus 1, my original function, is equal to A over x, which is 1 over x, plus bx plus c, which is -1x plus 0 over x squared plus 1. This is the result of the partial fractions. So if I want to integrate this, it suffices to integrate this because they are equal. Now, the right-hand side, of course, nobody would write it like that. We can clean that up as follows. So hence, the integral of 1 over x times x squared plus 1 dx is equal to the integral of 1 over x minus x over x squared plus 1 dx. And then we'll split that up as the integral of 1 over x dx, which is known, minus the integral of x over x squared plus 1 dx, which is not known right away. It's not one of our antiderivatives from the table, but it is something we know how to figure out. First guy is the natural log of the absolute value of x. How do I do this second guy? If this and only this was on the test, how would we do it?
You use sub for the x to the power squared plus 1.
Very good. This is a u sub problem because the derivative of the bottom is a constant multiple of the top. I like getting in the habit of using different letters, so I'm going to let z be x squared plus 1. And that means dz is 2x dx. So we're making this substitution in the second guy. This x dx is this x dx, which is 1/2 of dz. So you get 1/2 integral this x dx, again soaked up by the differential, x squared plus 1 is z. So this is also going to be a natural log term. That's not always the case, but you've probably noticed that you get a lot of natural logs in these partial fractions problems. Add on our plus c at this stage because now there are no more integrals. That's the step where you should add your plus c. And then finally, this z is x squared plus 1. I need to go back to that. So this is the natural log, absolute value of x, minus 1/2 natural log of x squared plus 1 is positive always, so I don't need the absolute values there, although it wouldn't be wrong if you included them. That would be fine either way. And that's it, we're done. Not too bad. Some partial fractions problems are a pain in the ass, right? Sometimes the linear system you get is quite large. But as a general rule, the outputs from these things are not terribly hard to handle. You can imagine that this coefficient, B, had come out to 0, and this coefficient, C, had come out to 1 or something else. Then you'd have a 1 or something else over x squared plus 1, no x's. That would give you an inverse tangent. So it's not always going to be natural logs. Right? There are other things that can come out of these. And you shouldn't assume that it's always going to be a natural log. You really do have to go through the procedure here. Questions on this one? I'm going to grab your textbook. We'll take 1 or 2 more examples here. Nope, it's not open yet. Oh, let's look at something challenging. Those are kind of boring. That's just a setup. We've done that. Yeah, this looks okay. All right. X cubed plus 4x. Okay, okay. Write this guy down. We're going to do example 5 together. Actually, you know what? Yeah, let's do it. Let's do it. Evaluate integral 2x squared minus x plus 4 divided by x cubed plus 4x dx. Okay, here we are. Again, the first thing we need to do is check if this is a proper rational function. If the answer is yes, then we proceed with our partial fractions. If the answer is no, then we need to do some long division. Degree of the top is 2, degree of the bottom is 3, 2 is smaller than 3, so yep, it is proper. Next, we factor. I can factor out an x here, and what's left is x squared plus 4. The roots of x squared plus 4 are plus and minus 2i, complex numbers. So x squared plus 4 is irreducible. Means that the PFD setup, similar to the last ones, a over x plus bx plus c over x squared plus 4. We clear out the denominators. On the left-hand side, we're left just with this numerator. And on the right-hand side, I'll have a times x squared plus 4 plus bx plus c. And remember to put this in parentheses. Tops and bottoms of fractions are always in implied parentheses. The x squared plus 4 would cancel, so this guy just gets the x. And as x goes to 0, remember you want to send x to whatever makes these pieces vanish. There's nothing I can do to make this piece vanish. He doesn't have any real roots. That's what it means to be irreducible. But I can make this whole piece vanish by sending x to 0. As x goes to 0, this becomes 2 times 0 squared minus 0 plus 4 equals a times 0 squared plus 4 plus b times 0 plus c all times 0. The left-hand side is just 4. And the right-hand side is 4a. This whole piece is 0. This is 0 plus 4. So a is 1 again. Now I rewrite this equation, having plugged in the A. I do like to name these sometimes. I'll call this star. So star becomes 2x squared minus x plus 4 equals A is 1. So this is just x squared plus 4 plus, I'll distribute the x, I get bx squared plus cx. And this is equivalent to 2x squared minus x plus 4 equals x squared plus bx squared is again 1 plus b times x squared. I'm just combining like terms. Plus cx plus 4. And now we can equate coefficients. Usually I call this 2 star. The coefficient of x squared on the left is 2. The coefficient of x squared on the right is 1 plus b. So 1 plus b has to be equal to 2. The coefficient of x on the left is -1. The coefficient of x on the right is c. So c has to be equal to -1. And the constants are equal to each other. 4 is equal to 4. Again, not useful, but true. And again, we get c for free. And the first equation, I can read off b. b is 2 minus 1, which is 1. So now my PFD is done, which means my function 2x squared minus x plus 4 divided by x times x squared plus 4 is equal to a over x, which is 1 over x, plus bx plus c, which is 1x plus -1 divided by x squared plus 4. Hence, the integral of 2x squared minus x plus 4 divided by x times x squared plus 4 dx is equal to the integral of this stuff, which I'll go ahead and split up. Integral 1 over x dx plus the integral of x minus 1 over x squared plus 4 dx. Again, the 1 over x integral is easy, nothing exciting to do there. What do I do with this thing? How do we integrate x minus 1 over x squared plus 4? It's worrying me a little bit. Oh, I see something in chat. U sub, sort of. If I have a fraction with a sum in the top, that's the same as the sum of those two fractions, right? With the denominator the same. So x minus 1 over x squared plus 4, this first piece is a natural log. Let's get that out of the way. This next guy can be split up as x over x squared plus 4, and that is a u sub, minus 1 over x squared plus 4, which is not a u sub. So we split up that fraction. That's how we do this. So I'm going to have the natural log of the absolute value of x, plus integral of x over x squared plus 4 dx minus integral 1 over x squared plus 4 dx. So the middle expression there, we evaluate using a u sub. And the last expression here, you have a choice. So you could jump in with the appropriate trig sub there, which would be x equals 2 tangent theta. Or you can use the formula that we proved in class. So one of the other things we have proved is that the integral of 1 over x squared plus a squared dx is 1 over a times the inverse tangent of x over a, plus a constant. This guy does require the little u sub. The u sub would be for the bottom. You would let z equal x squared plus 4. dz is 2x dx, just like last time. You get a 1/2 out. So the result here, you can check the details for yourself. It's going to be plus 1/2 natural log x squared plus 4. And then minus 1/2 inverse tangent of x over 2 plus c. The blue formula on the bottom right is one that you really do want to have in your noggin. Right? It really is worthwhile to keep this in your pocket. You don't want to have to do trig sub every time you see an integral like this. For one, it doesn't have a square root. So for a lot of people, the trig sub alarm doesn't really go off. And for the other, it's easy, right? There's integrals of this type show up so often. And there's like the trig sub always goes exactly the same. Everything cancels. Integral 1d theta. Theta is arctan of x over a. Like it's always this like identical grind that's not worth repeating. You should do it exactly as many times as it takes for you to remember the formula. And once you remember the formula, just use the thing. On the test, you will be allowed to use this freely. If you jump straight from this integral to this answer, I will give you a big thumbs up. And the same is true for this. This is a micro u sub, almost a micro u sub. I wouldn't mind if you jump straight from here to here, but if you have any doubt at all, you should check by doing the substitution. I would be more okay with saying you jump straight from here to the arctangent than straight from here to the log. But once you've done enough of these, they are quick, and it's okay if you do them quickly. If you don't do them quickly, of course, that's fine too. If you want to show all the steps, it's great. If you think there's any chance you might be wrong, you absolutely should show all the steps, because that way you can maximize your partial credit on the test. Questions on this part?
Yeah, where did you get the 2 from?
In each case, so here, the 1/2 out front is coming from the little u sub. So let me show you. The sub we would use there is z equals x squared plus 4. So dz would be 2x dx, and this means 1/2 dz is equal to x dx. So this x times dx here is 1/2 dz. So you'd have a 1/2 pop out after you cancel the x's, however you want to think of it. A 1/2 pops out, and then you'd have 1 over x squared plus 4 left. That's 1 over z. So that would give you your natural log. And in the trig sub, we went through the details, but in the trig sub over here, where you let x equal 2 tan theta, dx would be 2 secant squared theta d theta. And when you plug all of this in downstairs, you're going to have x squared. So this would be 4 tan squared theta plus 4. You factor out the 4, and you have tan squared theta plus 1. Which is secant squared theta. So your downstairs here would be 4 secant squared theta, and your upstairs, coming from the differential, would be 2 secant squared theta. The secant squareds cancel, and 2 over 4 is 1/2. Right? So those are the substitutions you would need to show the work for the latter two integrals. And I'm hoping that at this point you guys have practiced enough of these that they feel pretty transparent. But there's absolutely nothing wrong with going through those details. If you've forgotten or it just doesn't feel so super comfy, by all means. Other questions or comments here? Oh, my dog cam decided to turn off. There we go. Okay. Yeah, so these integrals aren't too bad. Kind of the worst case scenario where you have a repeated irreducible quadratic, you could have something like this all squared, and then you would have to do the trig sub. But those sort of things are quite rare. A repeated irreducible quadratic factor requires a pretty nasty downstairs. I have one more thing I'd like to look at from the partial fractions section before we begin to move on. And no, not this. That is, yeah, some substitutions you can make. So every now and then, let's take a look at the square root of x plus 4 over x. Every now and then you'll have an integral of a function that is not a rational function, but you can make it into one by doing an appropriate substitution. And those are sometimes called rationalizing substitutions. So this to be clear, is not a rational function. All right, the square root upstairs means this is not a rational function. However, we can make it into a rational function by doing the appropriate substitution. So here, if you sub, there's a few ways to think of it. I would like to write it like this. Sub u squared equals x plus 4. I'm taking the thing under the radical and calling it the square of something else because I want the square root to go away. This sort of maneuver works sometimes. In the settings where we've been doing trig sub, like the square root of x squared plus 4, it would not work because your differential would be too nasty. Taking the differentials on both sides here, I get 2u du equals dx. The x downstairs, so here's what we get if we start plugging this stuff in, right? I would have the square root of u squared upstairs. Downstairs here, I'll leave the x as x because maybe we don't know what to do for this. And dx is 2u du. So I have here a 2u du. Upstairs, the square root of u squared is just u. And then I still have this 2u du over here. Downstairs, x, this is one of those situations where you've done all the substitution stuff and you still have some of your old variable floating around. So the thing to do is to come back here and solve this for the old variable. Subtracting 4 from both sides, you get u squared minus 4 equals x. So this downstairs here is u squared minus 4. Now I pop out the 2, combine the like terms. Oops, sorry. Pop out the 2, and you have u squared over u squared minus 4 du. And this is a rational function. It's not a proper rational function. You would have to divide this top by this bottom in order to get this as a proper rational function. I can show you a fast way to do long division sometimes. This is a fun trick we call the add and subtract trick. I'll write the top as u squared minus 4 plus 4. So I've added 0 to the top. But I'm doing it in this way because now I can group some terms. I split this up. as u squared minus 4 over u squared minus 4 plus 4 over u squared minus 4 du. That first piece is just 1. And 4 over u squared minus 4 is 4 over u minus 2 times u plus 2 du. So now you would split this integral up. The integral of 1 du is just u. The integral of 4 over u minus 2 times u plus 2 would require some partial fractions. We don't have time to run through that, so I'll just say now split up and use PFD on this piece. That's the game. So these sort of substitutions show up surprisingly often. There are some other types of substitutions like this. So you get a function that looks kind of like a rational function, but it's got something wrong, either a square root in there somewhere, or maybe e to the x is in there, stuff like that. You can make substitutions to turn those into rational functions and then do the normal 7.4 thing, right? Partial fractions, long division, whatever it's called for. That's all we have time for today, guys. So I have to go ahead and end the meeting here. I'm going to publish your study guide this evening. Please get working on that as soon as you can. There will also be a part 2 homework for section 7.4 that I'll make available today as well. If you need to talk to me about anything, I have an office hour this afternoon from 1 to 2 p.m. Sorry about last Friday. I had a department meeting. What else? I think that's it. So yeah, if you need to talk to me, Canvas message, Discord, email, all that normal stuff, or just come by an office hour. And I will see you guys on Wednesday when we talk about 7.5.